Hello friends, so today we'll study the classification of elements and the periodicity in the properties. Now what it says that we can see from this screen that all the elements that are placed in a tabular form is nothing but the periodic table. So we can see all the elements present or known to the human being is placed in a single tabular form and it is called as a periodic table. Okay. Now what is the use of this? It is a basic for studying chemistry. Now how the elements were placed. So we can see what is the periodic table. It is an arrangement of all the elements that is known to the man with their increasing atomic number and the chemical properties. Okay, it is a very basic thing and it is very useful for student as the researcher also. Okay, now it also says that whatever the elements were present in universe, they have some trend and they are concerned with some families. Okay, so this element, this table says that all the elements that are present in the universe are related with each other in a certain thing and they are placed in the single table form. Now we can see it is nothing but the periodic table is considered to be the fundamental building block of the chemistry. Now how this table or the elements were placed, okay, and the periodic table was developed. Now we can see the very first scientist, that is the Dovereners, are he have developed or he have arranged the elements. Okay, now very first scientist who have arranged the element in a according to the atomic weight. Okay, so what he have considered that he have considered the triad rules. Please, the three elements, that is you can see here chlorine, bromine and iodine, can be placed in a single column. Okay, how it can be considered, it will place that we can see from this diagram. Chlorine is having atomic weight 35.5, bromine 79.9, iodine 126.9. Okay, what he says that these three elements can be placed in a single table, single column. Why? Because the atomic weight of first chlorine, first element, and the third element. Okay, so the average of the atomic weight of first element and the third element will be equal to the atomic weight of the second element. Okay, now we can see here various group he have developed. So lithium, sodium, potassium, okay, then calcium, strontium, barium were placed in a single column. Then so we can see here the average of the first group, first element and the third element, it will be equal to the atomic weight of the second element. So we can take an example of this chlorine, bromine and iodine. So if we consider that 35.5 plus 80 pound 2 will be equal to around 127. So that is how he have made of different groups, three groups of all the elements, and he have placed into the tabular form. So that is called as the Dovereners law of triads. Okay, but he has some drawbacks. So he was not able to arrange all the elements. That was just some drawbacks. Okay, now we can see the second law where second arrangement was given by Newlands. Okay, it is also famously called as the law of octaves in 1867. So what he have done, he have arranged all the elements in the increasing order of their atomic weight. That means we can see an example of this. So he have arranged the 7 elements arranged in the simple order of 1, 2, 3, 4, 5, 6 and the 7. How they are placed? According to increasing atomic weight. Okay, and what he says that second thing, he says that the he observed that every 8th element in the list beginning from any element shows that showed the repetition of physical and the chemical property. That means 8 element from here it will be fluorine, so it is placed in the first place. Okay, and the fluorine and the hydrogen will have a similar chemical physical properties. Okay, it will be the repetition. Okay, so because of its resemblance with 8 notes in the musical scale, it is called as a law of octaves. That means it is similar to the sa re ga ma pa da na pa da ni sa. Likewise, it is called as a musical scale, and that's why it is called as a law of octaves. Okay, again it will have some drawbacks. Okay, so in this law he doesn't have given the proper place to the inner glasses. Okay, so that was not used. Now we can see the next law is called as a Mayer's law. So Mayer's is developed a new theory that according to he have considered the all the elements were placed according to the atomic weights and the atomic volume. Okay, so here consider, we see this graph. You can see here it is on the x-axis is atomic number and molar volume. Okay, so here place all the element according to the increasing atomic number and the volume. Okay, so what he says that taking atomic number instead of atomic weight. Okay, so this graph reveal a periodic variations of atomic weights and atomic number. It may be noted that periodic variation repeat itself more or less as a regular. Okay, so that is how we arrange Mayer's arrange the. So these are nothing but the table form he have developed in 1868. Now the next law was developed by the Mendeleev. Now Mendeleev is nothing but it is the basic for modern periodic table. What he have done, he considered the new law. That means what he says that the physical and the chemical properties of the element are the periodic function of their atomic weights. So he considered all the physical and chemical properties is the function of their periodic function of their atomic weights. Okay, and he have arranged all the elements in a proper. So we can see that. So again it will have some different the drawbacks. Okay, so here doesn't define the position of hydrogen, lanthanides, actinides. Okay, he doesn't, similar elements were separated while dissimilar were placed in the same group. So these were some drawbacks of the law. Now again second was the Mosley modern periodic law. Again he have considered the same principle as that of Mendeleev's, and he have arranged all the element in a tabular form. From we can see here is from this picture. Okay, he have considered here. So in that Mendeleev's law there was no position for hydrogen. We can see that he have given a position for hydrogen here, and he have drawn this type of a tabular form where there was a 7 groups, 7 periods. Okay, 1, 2, 3, 4, 5, 6 and 7, and here it was the 8 column, 8 groups were there. Again from 1 to 7 the groups were again subdivided into the subgroups. So A B A B A B A B, where similar elements were placed. Okay, similar elements were placed in the subgroups. So that is how he have Mosley have developed a periodic table. Okay, now here dissimilar and similar elements were given a proper place. Okay, again it will have some drawbacks. Now this drawbacks was, again this was the basic for a modern periodic table. Again from this table only new modern table was have been derived. Now we can see the modern periodic table. So modern periodic table says that the classification of element is based on the more fundamental properties, that is the atomic number. So we can see here the atomic, all the elements were placed in this table is according to the atomic number. Okay, we can see here the first element is lithium, atomic number is 3. Then second is beryllium, it is 4. Then scandium, titanium, vanadium, chromium, all they are having a, they are placed according to the atomic number into the group table. Then The position of an atom is related with the electronic configuration. So we can see what is it says that all the electronic configuration which has a unpaired electron in s group, s orbit, were placed in the first group number from 1 and 2. It is called as s block element. Okay, and where the electronic configuration which is having unpaired electron in d group are placed in this from 3 to 12. Okay, it is called as a d group element or a transition element. Okay, again the electronic configuration where unpaired electron is present in the p orbit is placed in this from 13 to 18 group. Okay, it is called the p block element. So that is how the different elements were placed. Again, inert gas are placed at the end of the period. Okay, we can see all the inert gases are placed at the end of the period. Then last one, it is act as a strong tool. So this modern periodic table was considered to be a modern tool for the elements. Okay, again here various properties have been defined according to the position of the element in the group. So the metallic properties, so where we can see there were several trends were observed in the periodic table. So that the first one, atomic radius, then the atomic ionization energy, electronegativity, metallic character, all these were also considered while placing the element. So we can see here electron affinity. Now we can see from when we go from first group to last group, the ionization energy increases. That is the ion formation is, the more energy will be required for forming the ionize. Okay, then atomic radius decreases from last group to the first group. From top to bottom, atomic radius increases. Okay, now we can see ionization energy increases from bottom to top, and again electron affinity also increases. Now we can see the metallic character decreases. So here all the from p group to s group, the metallic character decreases. That means all of this will have a strong metallic character, and this element will have a less metallic characters. So that is how the modern periodic table was developed, and which is very useful for us to study in detail the chemistry. So that is all about our today's lecture. Thank you.